You ever wonder what's actually happening when you hit send on an email or fire up a movie on a streaming service? I mean, it feels like magic, right? But behind the scenes, there's this incredible, invisible system running the show, kind of like a digital postal service for the entire online world. Today, we're going to pull back the curtain on that system, TCP/IP. So let's kick things off with a big question. How in the world does a massive 4K movie file, we're talking billions of bits of data, get from some server in California through the absolute chaos of the global internet and land on your screen in Berlin? Perfectly intact? Not a single bit out of place. Well, that's exactly the puzzle we're going to solve today.
You see, sending information online isn't as simple as just flipping a switch. It's a massive logistical challenge. We can call it the digital delivery problem. And honestly, for it to work at all, it needs a super robust set of rules.
I mean, just think about it for a second. We're not sending one thing. We're sending billions of pieces of information, all at once across a global network made of countless different cables, routers, and devices. The real trick, the absolute challenge, is making sure every single one of those bits gets to where it's going, in the right order, with zero errors, every single time. You need a system for that.
And that system, the elegant solution to this huge problem, is a framework called the TCP IP model. This is it. This is the official rulebook for how everything on the internet talks to everything else.
So what is it, really? Well, the TCP IP model is basically the set of protocols, or rules, that dictate how data moves. It was actually developed by the US Department of Defense way back in the 1960s. Its whole purpose was to create a standardized, reliable way for different kinds of computers to communicate.
And here's the genius at its core. Instead of trying to send a huge file in one big chunk, TCP IP does something really clever. It breaks it down into tiny, manageable pieces called packets. The best way to think about it is like trying to mail a 1,000-page book. You wouldn't send the whole book at once, right? No, you'd send it as a series of postcards. This was a game changer because it meant the network could be messy. Each postcard could take a different route, and if one got lost, you'd only have to resend that one postcard, not the whole book.
Now, to manage this whole process, the model is broken down into 4 distinct layers. I want you to picture a 4-story digital post office. Every single piece of data you send starts at the top floor and travels down through all 4 layers to get packaged and addressed. And then, when it arrives at its destination, it travels back up those same 4 layers to be reassembled. All right, so let's follow one of our little digital postcards on its journey. We're going to start at the very top, on the 4th floor of our digital post office. We begin our journey at layer 4, which is called the application layer. This is the only part of the whole system that you, the user, actually see and interact with. It's where it all begins. You know, your web browser, your email app, your favorite streaming service, that's the application layer. It's where you generate the data you want to send, like the email you're typing or the movie you want to watch. It's designed to completely shield you from all the crazy technical stuff happening underneath.
So in our post office analogy, this is literally just you sitting down to write your letter. You're deciding what to say, who it's for, and you're not worrying one bit about how the mail service is actually going to get it there.
Okay, let's head down 1 floor. Once you've written your letter or your data is created, it gets handed off to layer 3, the transport layer. And this layer is all about one thing: reliability. Think of the transport layer as the quality control manager of the post office. It takes your data and uses a protocol called TCP, that's the T in TCP IP, to chop it up into all those numbered postcards or packets. It keeps track of every single one, checks for errors, and makes sure they can all be put back together perfectly on the other end. Back to our post office, this is the part where you take your long letter, you write it out on a stack of numbered postcards, and you arrange for delivery confirmation. It's the step that guarantees that every single piece arrives and can be read in the right order. Okay, next up, those numbered packets are dropped down to layer 2, the internet layer. You can think of this as the global logistics department. Its job is all about addressing and routing. This is where the IP and TCP IP comes into play. The Internet Protocol stamps each and every packet with a destination IP address. Then, routers all over the world read that address and just forward the packet along, from one network to the next. What's wild is that it doesn't care about the best route, just any route that gets it closer to its final destination. And in our post office analogy, this is super simple. This is the addressing station.
Every single postcard gets stamped with the complete destination address and, of course, a return address before it's sent out into the world.
And that brings us to the ground floor, Layer 1, the link layer. This is where the digital bits and pieces finally meet the physical world. This is where the rubber meets the road, so to speak. The link layer takes our fully addressed packets and gets them ready for their actual physical journey. It formats the data so it can travel over an Ethernet cable, or be broadcast as a Wi-Fi signal, or be sent as light down a fiber optic line. It's the final packaging step before it's out the door.
In our analogy, this is the local mail truck. It's the truck that pulls up, picks up your whole stack of addressed postcards, and makes sure they get on the right plane or the right train to start their long journey. So we've seen how all 4 layers work together in this beautiful stack. But let's zoom in on the 2 superstars that give the whole model its name, TCP and IP. Because even though they work as a team, they have totally different jobs.
The best way to think about them is as 2 key employees in our digital post office. TCP is the super reliable, meticulous organizer. He's the one numbering every package and triple-checking for delivery. And then you've got IP. IP is the fast, no-nonsense router who just looks at the address and sends the package on its way as fast as possible.
And this table here really breaks down their partnership perfectly. Look at the type row. IP is connectionless. That means it just slaps an address on a packet and fires it off. It doesn't worry about errors or whether it arrives. That's TCP's job. TCP is connection-oriented. It establishes a formal connection, it manages the flow of data, it checks for errors, and it makes sure everything gets reassembled. So here's the bottom line. IP gets it there, TCP makes sure it gets there right.
So when you put all of that together, the 4 layers, the partnership between TCP and IP, you get this incredibly elegant system. It's truly the internet's invisible engine, just humming along in the background, making sure our entire digital world, well, works.
You know, this quote from our source material just says it all perfectly. The TCP IP model isn't just part of the internet, it is the fundamental backbone that allows all of these millions of different devices and networks to connect and actually share information with each other reliably.
And at the end of the day, why does any of this matter to you? Well, the model's flexibility is the reason your Apple iPhone can talk to a server running Windows. Its insane scalability is the reason the internet could grow from a tiny military experiment into a global network with billions of devices. And its built-in reliability is the reason you can trust that the file you download is the exact same one that was sent, which makes everything from banking to video calls possible.
And that leaves us with one last kind of mind-blowing thought. This system, this incredibly robust and flexible system that we rely on for everything, was designed over half a century ago, in the 1960s. The fact that it still runs the modern world is a testament to its brilliant design. But it does make you wonder, as our world gets more and more connected, what will the internet's backbone look like another 50 years from now?